Get ready to witness the raw power of fire transforming metal into might. Inside this steel mill, heat reaches 1,500 degrees Celsius, melting raw materials into the backbone of industry. It begins with a massive blast furnace. Iron ore, coke, and fluxes are fed into the top, while superheated air blasts upward, triggering intense chemical reactions. What emerges is molten iron, tapped and channeled into ladles that carry it across the plant. In the converter, oxygen is blown into the hot iron to remove carbon and impurities. Sparks fly, smoke billows. It's steel in the making. Molten steel is then cast into slabs, glowing bright orange as they cool. The rhythm of cranes and ladles above is constant, never stopping, never slowing. It's a flow that defines the entire production floor. Slabs are reheated and rolled in a series of powerful machines. Each pass reduces thickness and increases length, creating long sheets or coils. Watching steel behave like clay at these temperatures is mesmerizing. Advanced automation controls every stage, from ladle movement to mill pressure. It's a harmony of human oversight and robotic precision. Along the way, samples are taken, tested, and analyzed to ensure every batch meets exact standards. From raw ore to final product, this is transformation on an industrial scale. And every strike, every spark, tells a story of heat, force, and control. A double-column vertical turning lathe built for heavy-duty performance. From the moment the spindle lowers onto a massive workpiece, you can feel the power in every rotation. With a milling capacity of 317 cc per minute, it combines robust turning and milling functions into a single, precise operation. Its double-column design ensures greater stability and accuracy, even during intense cutting cycles. Advanced cooling systems reduce thermal deformation, keeping tolerances tight. Whether shaping large components or machining fine features, this machine doesn't miss a beat. Watching it work is like seeing muscle and precision in perfect synchronization. Welcome to the forge of modern molds, where aluminum is carved with micrometric mastery. A blank block of aluminum, thoroughly chosen, begins its journey toward becoming a precision tool. The block is first secured onto the CNC machine's table using heavy-duty clamps. Alignment is measured twice, then locked. Even the slightest misplacement could compromise the mold's final dimensions. Once ready, the spindle hums to life. A roughing end mill cuts into the block, removing large chunks of material in broad, rhythmic passes. After roughing, the machine switches tools. This mill is fully automated, managing dozens of tool changes without operator input. A finishing cutter then enters the scene, carving smooth surfaces and crisp edges. You can almost hear the difference. Rough planes become refined curves. Between cycles, the machine pauses briefly to recalibrate tool length and check spindle load. It's a moment of mechanical mindfulness that ensures consistency. Next, the machine taps threads where needed, drills holes for mounting, and verifies depth with built-in touch probes. Every movement is recorded. Nothing is guesswork. Specialized fixtures may be used to rotate the mold mid-process, allowing complex geometries to be machined in one continuous setup. Throughout production, vibration sensors monitor spindle behavior. If chatter starts, feeds and speeds adjust automatically. It's a self-correcting system, combining human setup with smart automation. Tool wear is tracked in real time. As soon as tolerance thresholds are approached, the tool is swapped before defects can form. Multiple axis movement, up to 5 axes, allows for compound angles and undercuts, all within a single mount. It's like sculpting in motion. Each cavity is machined with layered depth cuts, gradually removing material to avoid deflection and ensure a clean finish. Sharp corners are automatically filleted unless the CAD file specifies otherwise, reducing stress points during molding. Some details, like cooling channels, are machined with deep hole drills using high-pressure flushing to remove chips. For textured surfaces, the machine runs slower and uses specialty ball end mills to preserve pattern accuracy. Thread milling replaces tapping for high-precision threads, especially in hardened sections of the mold. Certain features, like slide cores, require side-access machining, made possible with indexed rotary tables. Tool paths are generated from CAM software, but adjusted manually for areas needing tighter tolerances. Fine engraving, such as part numbers or alignment marks, is etched using micro end mills with tip diameters under 0.5 millimeters. Blind pockets are air-blasted post-machining to clear trapped swarf before final inspection. For curved parting lines, the CNC follows multi-axis sweeps, blending contours seamlessly without seams. Corner break radii are introduced precisely where needed to prevent stress concentration during injection. Tight clearance zones are cut in multiple shallow passes, maintaining tool rigidity and avoiding deflection. Once machining is complete, surfaces may be polished by hand or blasted depending on mold requirements. The result? A mold that matches design to a fraction of a human hair. Every curve, every cavity perfect. This whole process, from raw aluminum to certified mold, can take hours or days, depending on complexity, but each minute in the machine is invaluable. From clamp down to quality check, CNC mold making is the heart of modern manufacturing, where swarf meets silicon and aluminum is shaped into tools that shape everything else. Metal arrives in bulk, and the plant's first job is to make it usable. A magnetic separator pulls out iron scraps, and a vibratory feeder carries 4 tons of material into a tilt rotary furnace. Oxygen-fueled burners kick in, melting the scrap with controlled intensity. When the metal reaches fluidity, it's transferred into a holding furnace that tilts on its axis. Inert gas is injected through a porous plug, refining the melt and removing impurities. At this stage, the temperature is precisely tracked. Every degree matters to preserve alloy integrity. The holding furnace stabilizes the metal before it moves to casting. Operators monitor temperature gradients across the surface to ensure homogeneity. Molten metal then flows into a 220-cavity ingot casting machine, where water-cooled molds harden the metal. Each cavity cools at the same rate, producing uniform ingots. These ingots are then inspected visually before stacking. A robot arm picks each ingot, places it on a pallet, and sends it through a water-quenched tunnel, ensuring rapid cooling and preventing heat stress. Sensors verify cooling rate, and surface temperature before the ingot is moved. Surface checks detect any cracks, and defective ingots are diverted automatically. Meanwhile, the plant's PLC system logs every operation in real time for traceability. Conveyor belts move ingots smoothly down the line, guided by laser positioning systems. While all this happens, sensors monitor emissions continuously. Exhaust gases pass through scrubbers and filters, and real-time data ensures pollution stays within strict limits. Water usage and quality are tracked to prevent environmental impact. Every temperature, flow rate, and gas reading is tracked by centralized software. Automation and design work together seamlessly. The rotary furnace rotates, ensuring even mixing. The vibratory feeder preheats the scrap, and gas injection fine-tunes the alloy properties. Maintenance robots inspect critical weld joints during operation. The sequence continues rhythmically and relentlessly, transforming random scrap into precision ingots ready for reuse. Control systems adjust parameters automatically, adding just enough gas, adjusting tilt speed, maintaining cooling flow. Every variable is optimized. Calibration routines run weekly to maintain sensor accuracy. Audits ensure traceability from scrap to ingot. No step is wasted or overlooked. Final ingots stack perfectly, drip-cooled, and aligned for shipment. Shipping manifests include batch data and quality metrics. Hundreds of tons are processed each day. Sensors ensure quality and environmental compliance down to the last detail. Staff conduct random sample tests to verify chemical composition. It's the culmination of metallurgy, robotics, and control systems working in harmony. Watching it run is a testament to how smart design and automation redefine sustainability. Every ingot here is a story of efficiency, responsibility, and engineering excellence. Brass honey, a tangled mess of old faucets and fixtures, enters the line. The 315 kilowatts hammer shredder roars to life, crushing and tearing the brass into fragments at a rate of 6 to 8 tons per hour. What a brutal, yet satisfying start. A magnetic separator kicks in next, pulling out any remaining iron pieces with impressive accuracy. Non-ferrous metals continue onward, separated from contaminants. Material then flows into a rotating trommel screen, where it's sorted into small, medium, and large sizes. Watching the shredder line in action is like seeing chaos sculpted into order. Every section of the system, conveyor, shredder, magnet, and sorter, works in perfect rhythm, maximizing recovery and efficiency. This is scrap management, engineered for precision. After weeks of cooling, a 136-ton casting is carefully lifted from the mold pit, still radiating heat. Transporting it across the foundry is a logistical feat. In the cleaning hall, workers spend days removing sand and casting residue. It's slow, gritty work, but essential before final inspection and delivery. Deep foundation solutions in action: secant piles, CFA, displacement, offshore shafts, cutter and auger soil mixing, mass ground improvement, and shoring. Every pour, every lift, copper refined through robotics. Molten copper flows into rotating molds, glowing red, thick, and alive. As the turntable completes its cycle, solidified copper anodes begin to emerge, still radiating heat. A robotic arm swings into action, gripping each one with surgical precision and lifting it from the mold. Timing is critical. The robot adjusts seamlessly to each rotation of the casting table. Once lifted, anodes are carefully aligned onto a conveyor for downstream processing. Sensors monitor every motion. Nothing is left to chance. Each step is fast, coordinated, and repeatable. It's copper casting elevated by automation. Efficiency, control, and heat moving in perfect rhythm. This is no ordinary fabrication. This is the birth of a 40-foot diameter regenerator head built from the ground up by Contract Fabricators Inc. Over the course of a year, 11 massive cyclone pairs were installed with millimeter-level precision. Welders, fitters, and crane operators worked in sync to shape steel into function. The scale alone is jaw-dropping, but what's more impressive is the accuracy. As the final touch, a circular dome is carefully craned into place, sealing a year of labor beneath a steel crown. One last lift, and the beast is whole, ready for shipment. We're catching the process midstream, where deep drawing transforms pre-cut blanks into precise 3D forms. This GNMLT2800 system uses multiple forming stages to shape flat metal into complex parts. Each station performs a precise task: bending, stretching, or punching, while mechanical arms transfer the part along the line. The press moves with incredible force and timing, yet every motion is smooth. Watch closely. Each stroke transforms geometry with surgical finesse. It's power, repetition, and engineering working in perfect unison to turn sheet into shape. Each bearing, radial, thrust, or slewing, is engineered from certified raw materials with diameters reaching up to 6,000 millimeters. After heat and protective treatments, every unit undergoes ISO 14001-based quality control before being shipped worldwide. Foundry 6 Kekia. As the 350 HP Synchronous motor spins to life, torque and timing align in flawless harmony. At 2,400 volts, power flows in, fields align, and momentum builds fast. You can almost hear the surge, controlled, deliberate, unstoppable. Before the forging, before the heat, every steel journey starts with a single perfect cut. A solid billet slides into position, no clamps, no pause. From the side, a hydraulic arm presses briefly against the steel, signaling the system. Then, in a single smooth motion, the saw blade descends. Sparks flash as metal yields. Once cut, the billet doesn't wait. Momentum carries it forward, rolling off the cutting station like it knows where to go. There's no manual handling, no wasted motion. The system is calibrated for speed and repeatability, cutting dozens of billets in rapid succession without resetting. Watching it work feels like watching confidence. Every action brief, precise, and just enough.